So good morning all of you. We will see the new chapter, heat exchanger. Now by definition, heat exchanger, it is a device which is used to transfer the heat from hot fluid to cold fluid in minimum effort or minimum cost. Okay, so it must be cost effective. If any instrument is any instrument is not effective, then there is no use of that instrument. Okay, now for that we are having the optimization, the separate branch of engineering or mechanical engineering, sub branch of mechanical engineering. Okay, so anything device which we made, it must be effective. It means that we are making machine always to minimize the human effort. Okay, why we are developing the systems or machines? To minimize the human effort. Now along with that, it must be minimizing or maintaining the cost effectiveness. Okay, it means that let us say we are having one machine which works at the 100 units at 100 rupees, and manually or by using the previous machine we are uh, completing the same task in 10 rupees, then our new machine is not effective. Okay, that's why we are using the term in definition that it must be effectively. Okay, so it must be cost effective, it works at a maximum rate and minimum investment. Okay, so by definition, heat exchanger, it is a device which is used to transfer the heat from one fluid to another fluid with maximum rate and minimum investment and running cost. Okay, so it is the definition of heat exchanger. Now in heat exchanger, temperature of each fluid changes as it passes through the heat exchanger. Hence, the temperature of its dividing wall between the fluids also changes along with the length of heat exchanger. Now, there are some examples of heat exchangers like intercoolers, condenser, evaporators, regenerators, automobile radiators. Okay, these are some examples of heat exchanger. Now we will see our main point. It is types of heat exchanger. In examination, they are asking write a note on types of heat exchanger or explain the types of heat exchanger. Now in that question we have to draw the figures and explain the each heat exchanger one by one. Okay, so in types of heat exchanger, the heat exchangers are divided into the two types mainly, that is indirect contact type and direct contact type. Now in indirect contact type, the fluids are not mixed with each other. Okay, the fluids whatever you are having, hot and cold fluid, they are not having any physical contact in between them, and in direct contact they are directly get mixed. For example, cooling tower, it is the best example of the direct type of heat exchanger. Now in indirect type of heat exchanger, our first is tube in tube type of heat exchanger. Now in tube in tube type of heat exchanger, we are having two tubes. From one tube there is cold fluid is flowing, and in another tube hot fluid is flowing. Okay, now second tube is present above the first tube, so in between the cavity of the first tube and second tube, the second fluid is flowing. Okay, now as per the direction of that flow, the tube in tube type of heat exchanger is also divided into the two types. First is parallel flow and counter flow heat exchanger. Now in slide, in first figure, we are having hot fluid and cold fluid flowing left to right, so it is in the same direction, that's why the fluid flow is parallel to each other. Okay, now the temperature distribution along with the length of heat exchanger, it shows that from left hand side, the THI, that is temperature of hot fluid at inlet, is going to decrease and it becomes the THE or THO, that is temperature of hot fluid at exit or at out. Similarly, also cold fluid is flowing from left to right, so TCI, that is the temperature of cold fluid at inlet, it is going to increase because absorbing the heat from the hot fluid, and it becomes TCE, that is the temperature of cold fluid at exit. Okay, similarly in counter flow heat exchanger, the flow of hot fluid and cold fluid are exactly opposite, in opposite direction. Okay, that's why hot fluid, if hot fluid is flowing from left to right as shown in figure, then cold fluid is flowing from right to left. Now efficiency of that counter flow heat exchanger is more than the parallel flow heat exchanger. Okay, it means that in minimum length or for the same length of a heat exchanger, the counter flow heat exchanger provides the more heat transfer than the parallel flow heat exchanger. Okay, now its temperature distribution as shown in figure. Now that temperature distribution is very much important, because while solving the problem we are taking consideration of these figures, and if you understand these figures properly, then it's quite easy to solve the problem. Okay, so next one is tube and shell type of heat exchanger. Now if you observe the figure, here we are having one container, and on that container we are having provided some tubes. Okay, now in this container, if you see in first figure, we are having pipes providing pipes joining the left hand side of container to right hand side container. Okay, now through that cavity one fluid is flowing, and in between the pipes there is another fluid is flowing. Now that two fluids are separated by using that pipes and cavity. So while flowing the hot and cold fluid in between them, they are exchanging the heat. Okay, now as they are exchanging the heat, we are getting the heat transfer. Also, to increase the efficiency, we are providing the partition. If you can see in the figure, you can easily get there. We are providing some partition inside the container. Due to that, our Shear inlet type of fluid going to flow from downward, then upward, then downward, then upward, and then going out by the shell outlet. Okay, in figure it exactly shown. Now there are subtypes similar to, the function is the same, but to increase the efficiency we are providing the different types of constructions here. Now in second figure you can say the cold fluid inlet, it is from the left hand side top. Now due to the partition, it doesn't go directly through that directly towards the cold fluid outlet. It has to flow as shown in figure from left to right, then from right to bottom, and then bottom to left, bottom right to left, bottom and outside. So as flowing area or flowing time through the heat exchanger is increased, that's why amount of heat exchange also increase. Okay, so heat exchange is also depends on the time in that our fluid is flowing through that our heat exchanger. So this is the tube and shell type of heat exchanger. As per the purpose as per the purpose in heavy industrial applications, we are using this kind of heat exchangers. Now our third type is matrix type of heat exchanger. Okay, now if you can see figure number 1, so in that first figure, in matrix type heat exchanger, from tap number 1 we are providing the one fluid, and that fluid passes through that matrix, and from tap number 2 it goes outside. Now in figure, if you can observe properly, then you can understand that in this type of heat exchanger, the hot and cold fluid are not present at the same time inside the heat exchanger. It means that at first for a 1 minute, let us say, hot fluid comes inside the heat exchanger, it goes through the matrix and flows to the B. Now this happens for the 1 minute only. Okay, so we are taking just one example, that is, it is for the 1 minute only. So while that transfer or while that flowing, our matrix collects the energy from the hot fluid. Okay, it takes some energy from the hot fluid, and hot fluid becomes the loses its temperature. Now our matrix now having the energy inside it, then close the tap number A and tap number B and open the cold fluid tap C. So due to that, cold fluid comes inside the heat exchanger. It collects the energy from the matrix while flowing through the tap number D. So this happens also for the 1 minute. So for the successive time period, we are flowing hot fluid inside the heat exchanger and then cold fluid inside the exchanger. Okay, now while flowing through that matrix, it collects the energy and matrix becomes cooler and our cold fluid becomes hotter. So our heat exchange happens between these two heat exchangers, in this heat exchanger. Now to avoid this confusion, or sorry, it is not confusion, to avoid the opening and closing of the valve, we are using the second type of heat exchanger, which is known as the rotating matrix type of heat exchanger. In that we are having cold fluid flowing through the one cavity, that is downward cavity, and hot fluid from the top cavity. So, and our matrix is always rotating. Now while rotating our matrix, now you can see that matrix strips are number of strips, that is in second figure you can say 1 2 3 4 5 6 7 8 9 10 11 12 15. Okay, around 15 strips are at the top side. Now it is slowly rotating. Now that's while rotating from the hot side, it collects the energy from the hot fluid, and when it goes through the cold side, it releasing the energy. Now due to that collection and releasing energy, we are getting transfer the heat from the hot fluid and cold fluid, and there is also we are not having any kind of mixing of the hot fluid and cold fluid. So this is also the indirect type of heat exchanger. Okay, now there is another example of compact type of heat exchanger. Okay, there are, in compact type, the heat exchanger pipes or fluid flow is exactly perpendicular to each other. Okay, now this is also used to enhance our number of heat exchange amount of heat exchange in between the fluid. Okay, by figure you can easily get, we are having one fluid flows from the left to right and another is from the back side to front one. Okay, because of this flow we are getting the exchange of heat. Now there is major type of heat exchanger, is direct contact type. Now in direct contact type heat exchangers, fluids are mixed with each other. Okay, so in direct contact, exchange of the heat takes place by the direct mixing of the hot and cold fluid, and transfer of heat and mass takes place simultaneously. Okay, so it is not just the transfer of heat, it is also transfer of mass. Now if you are visiting the sugar factory, at that in sugar factory, the vapor, or to regenerate the water, we are using the cooling towers. In that cooling towers, water vapors are flowing, and from upper side of that tower we are having some showers, water showers. So while the droplets coming down, it collects the water vapors along with it, and it minimizes its energy. That is, transfer of heat happens between water vapor and water droplets, and we are getting the extra amount of water at the bottom. So actually it is the purpose of the cooling tower. Now in cooling tower, it is also nothing but the one type of the heat exchanger. Okay, then there is one major equation we can use in the heat exchanger. Okay, now that equation is known as energy balance equation, and we know that heat exchanger having two fluids, one is hot and one is cold. Now as per the first law of thermodynamics, energy neither be created nor be destroyed. Okay, what is the law? Energy neither be created nor be destroyed, it is only convertible. So in indirect type of heat exchanger, if we are taking example of tube in tube type, also in syllabus of our problem purpose we are having tube in tube type of heat exchangers. Now when hot fluid flows from left to right and cold fluid also from left to right, while that flowing, they are exchanging the heat. So amount of heat released by the hot fluid must be equal to the amount of heat gained by the cold fluid. It is because of the first law of thermodynamics. It means that heat lost by hot fluid equals to heat gained by cold fluid. Okay, So Q is equals to mCp delta T hot equals to mCp delta T cooled. Okay, Q is what? Q is heat transfer rate. Okay, so m means what? It is mass flow rate kg per second. Now for hot fluid it is mH. Cp means what? It is specific heat of the hot fluid, Cph, and Cpc it is specific heat of the cold fluid. Now Thi delta T for hot fluid is Thi minus The, and for cold fluid lower T is Tce minus Tci. That is, always subtract from lower temperature from higher temperature. Okay, so by using this energy balance equation we can find any missing temperature from the problem. Okay, for in problem we have to always use first this energy balance equation. It gives us the any value. It may be mass flow rate or specific heat or any temperature from hot fluid to cold fluid. So it is very much important. Okay, so due to the time restrictions we will stop here. You have to study it properly, and then in next lecture we will see the log mean temperature difference method for the heat exchanger analysis. Okay, so thank you.